Hello, welcome. There. Now the audio on YouTube should be off. Yeah, welcome back. Merry Christmas, everyone. Oh wait, there is a 25th as well. I thought this only went up to 24. So we actually have 3 days I haven't done. I thought it was only 2. I'm not sure if we'll be able to do all 3 today. It depends a bit on how long they take. So here in Norway, we celebrate Christmas on the 24th. So we were actually yeah, as I said, we celebrate Christmas on the 24th. So we actually had our Christmas celebration yesterday. Had a lot of fun with the family and got some cool presents as well. And none of them here, unfortunately, because I left them at my dad's place because I was walking home in the middle of the night. So yeah, let's have a look at day 23 here. I've already made the folder, but I haven't looked at any of this yet, so I don't know what we're up to. Crab cups. Ah, right, we were playing the card game with a crab. The small crab challenges you to a game. The crab is going to mix up some cups, and you have to predict where they'll end up. So I guess the like shuffling cups thing. The cups will be arranged in a circle and labeled for you guys clockwise. That's counterclockwise for me, but I think this is flipped. Yeah, that was flipped. So yeah, that's my puzzle input. Is the clockwise labeled cups. For example, if you're labeling where 3, 2, 4, 1, 5, there will be 5 cups in the circle. Going clockwise around the circle from the first cup, the cups would be labeled 3, 2, 4, 1, 5. I guess that was reversed for you guys. And then back to 3 again. Before the crab starts, it will designate the first cup in your list as the current cup. The crab is then going to do 100 moves. Each move, the crab does the following actions. The crab picks up 3 cups that are immediately clockwise of the current cup. They are removed from the circle. Cup spacing is adjusted as necessary to maintain the circle. The crab selects a destination cup, the cup with a label equal to the current cup's label minus 1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value of on any cup's label, it wraps around to the highest value on any cup's label instead. The crab places the cups it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. Right, so that would be one of the ones we picked up. Right. For example, suppose your cup labeling were 3, 8, 9, 1, 2, 5, 4, 6, 7. If the crab were to do merely 10 moves, the following changes would occur. So it starts with this as the current cup, it picks up these, and it ends up on this one because that's 3 minus 1 is 2. And then it inserts these after the 2. So in between the 2 and the 5 here, it have inserted the ones it picked up. And then it yeah, so 2 subtract 1. Why? Oh, right. We pick these up again, and we go to so 2 minus 1, but we have already picked up 1, so we can't choose that one. So we go to 0, but that is below our lowest number. So go back up to the start. 8 and 9 are also picked up, so we end up with 7 as the destination. So after 7, we take and insert 8, 9, and 1 after the 7, and we take the next cup. Right. Okay. Seems easy enough. In the above example, the cup's values are labels as they appear, moving clockwise around the circle. Yeah, the current cup is marked with, after the crab is done, what order will the cups be in? Starting after the cup labeled 1, collect the other cup's labels, clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. In the above example, after 10 moves, the cups clockwise from 1 are labeled 9, 2, 6, 5, and so on, producing this string. If the crab were to complete all of 100 moves, the cups after 1 would be this thing. Using your labeling, simulate 100 moves. What are the labels on the cups after 1? And this is my puzzle input. So, same as I did last time we had something like this, I'm just going to pop that into a file, just for sort of to make them all the same. And as a data structure for these cups, I think we actually want to do a linked list. Well, I guess we could use a sequence. We could do a sequence because sequences are just resizable memories, resizable arrays of data. The problem with those is that, so for example, picking out 3 things from the array and inserting them somewhere else would mean basically rewriting the entire array, right? So we have cycle. I mean, we could do something like this to go to the current one, and then delete these. But I think a linked list is the better option. So basically, a linked list, pretty much what it sounds like. Instead of storing them in one contiguous part of memory, it's going to be stored in chunks around in memory with pointers or name references to each of the things, and that will cause them to sort of be a list just by going to the next one. That also means that to take a piece out of the list, we can just rearrange those pointers, and now this part isn't part of the list anymore. Nim has a module for this. It's called lists, which has single linked list, where each node only links to the next one. A double linked list, where it links both ways. Singly linked rings, which is a circular list, which is what we're going to be using. And doubly linked list, which is the same again. Each node knows about its next and its previous node in the list. I'm not sure if we need single or double. We'll just go with double. Use init doubly linked ring proc to create an empty ring. Do we actually need to initialize these? No. I mean, calling this procedure doesn't do anything. Okay. So we're gonna import lists. We are going to need our data, but I'm gonna let's have a look at this data actually. Day 23. Right, so it's basically all the numbers from 1 to 9, isn't it? 1 to... Yeah, this is 9 characters long. I wonder if all of them have all... I mean, not that it really matters, but... But yeah, anyways, let's start with this thing. Oops, that seemed like it did something. Yep, there. And then our ring. I mean, we'll call this doubly linked ring. That's what it was called, right? Unit doubly linked ring. Yeah. And we need to give it a type. Just give it an int type. And then for C in data, so for each of the characters in data, we are going to add a node. So what can we do? We can do prepend or append probably. Yeah. Remove. We are going to ring.append, and here, so we can do this to get the ordinal of this character, but that would of course be the ASCII value of the character. But one neat little trick is that the ASCII character, or the ASCII of 0 minus the ASCII of whatever, will just give us the number. So I'm not sure we can echo rings actually. I'm not sure what happens then. It might just give us one pointer. Ah, no, it gave us the whole thing. And that was of course the wrong way around. This should be C and this should be that. So we get the positive numbers. And echo out data as well. Yeah, so that looks right. We have all our characters now in a ring. So this is also connected to this, even though it might not look like it. So we need a current cup. So the current cup is ring dot head. It should be. So the way these are built up. Let's see. Should have a type definition here. So because of the sort of the things you end up doing when you use linked list is so close to the representation of the linked list itself, these are all sort of exposed. So a doubly linked ring has a head pointer, or reference rather, to this doubly linked node. Oh, it's not even a reference. And oh yeah, it's a reference object, right? So these have a next and a previous and a value. So if we, I'm not sure if these have a string. No, but we can echo out the value of this, and that will give us 3. And we can also do stuff like the next one's value, which should give us 8. And we can do the last one's value, which is going to be 7. So that's fine. And then we need to take out 3. So it picks up the 3 cups that are immediately clockwise of the current cup. That means taking current cup dot next. So 3 down. So we need to store this, obviously. Taken cups is just this thing, and then say current cup dot next has to be equal to current cup dot next dot next. That would skip 1, 2, 3 cups, and current cups, now new next ones, previous node needs to be set to the current cup, because remember we're doubly linked. So each node knows about both of its neighbors. So this one is now updated to be the one 3 down the line, and that one's previous node is set to be our node. Taken cups is just the reference to the one that was after the current cup. We don't actually change those, so this will still be able to reference all of them. But that doesn't really matter to us, because we're not going to be working on the taken cups apart from putting them in later on. Right. So if we now print out the ring, we should see that we have taken out 8, 9, and 1, which is what we wanted. So if we print out the taken cups dot value, that should be 8. The one after that should be 9, and this should be 1. Yep. But remember, these aren't, we haven't updated this, so they will still keep a reference to all of them. But that's fine. Don't echo those out. I should just remove that. Now we have this. We have taken these out. So the destination is the one equal to the current cups label -1. If it would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value. So we know that that is 1 and 0. 1 and 9. But just so we can test with different stuff, we are going to store the minimal cup and the maximum cup number. Yeah. And then we are just going here to say that the cup is equal to this thing. That is that. And then we are going to say that min cup is the smallest of min cup and cup. And similarly here, we are going to replace min with max. So now we have, and since I set this one to int high, so the first cup will be obviously lower and it will obviously be higher than this. So that should give us the min and max. That gives us the minimum and maximum cups. So 1 and 9. Good. We can remove that. And the algorithm here, so it says like it picks up the cup label to blah blah blah. If this would select one of the cups that was just picked up, it will keep subtracting one. So we are going to say our want cup is current cup dot value -1. And then, so this one has it is going to be some kind of an iterator, or not an iterator, but it's gonna, contains. Searches the list. So this will just like go through them and returns a bool, which is perfect because we can then do while ring, or while the ring does not contain the cup we want, one cup when it's equal 1, or we can do decrease the want cup, and if want cup is smaller than min cup, we set want cup to max cup. There's probably a more succinct way of doing that, but that should work. And then after it has found the one that we're looking for, so in this case we'll look for 2, then it's gonna place them immediately clockwise of the destination cup. So we have now found the destination cup. We are going to insert this back in, or we actually haven't found it. We've just used contains. We actually want to find it. So we could return nil, but we don't have a walrus operator in them. A walrus operator is named because it looks like that in most languages, kind of like a walrus if you tilt your head. And basically what that would allow us to do is write a statement here that assigns something and also returns something. We can of course do it in different ways in NIM, but we're just going to do the simple thing and just look for it again. So we are going to set the current cup to be equal to the want cup, and we know it is in here because this loop has completed. And now we are just going to say the current cup dot next is equal to the taken cups, and taken cups dot previous is obviously equal to the current cup. And now we do the clipping. So now we need to say the third of the taken cups must point to whatever this was pointing to. So we can actually do that up here. So taken cups dot next, that is the cup after the cup that we took. And then the one after that, and then the one after that. So that would be the pointer or the reference coming off of the third cup should be equal to the current cup's next one, and the current cup's next one's previous one should be equal to this one. Oh, but we can't do that after. Taking cups next dot next dot next is equal to that. So current cups and next, yeah, that should be taken cups dot next dot next. Current cup dot next, yeah. And we set the current cup dot next there, and I'm just gonna rewrite this to we can keep it like that. So that should have inserted it again. We can echo out the ring just to make sure. So this running this now should snip this out. 891 should be taken out of here and placed in between the 2 and the 5. Yeah, seems like that worked. Good. And we were supposed to run this for. Okay, so let's do 10 moves of this. We are doing 10 loops of this. Yeah, we can do it like that. And we can just do this and just echo out the round number. So if we now get the 1, so start as ring dot find the one with label 1. These are ints. Then we should. Does this have a length? No. But we have our length sort of in this string. And we should then get all of the numbers without the 1. So starting from 1, we want our order just be an empty string, and then while let's call this something else. While the or this is gonna be just current. Whatever. We can just reuse the current cup variable there. And while the current cups dot value is not 1, so as long as it isn't, as long as we haven't gone back to the start, we go to the next one, and order that should start off at the next. Otherwise we just quit immediately, because the value of this is obviously 1, because that's one we've been looking for. We go to the next one, and we add onto the order the current cup dot value as a string, and then we go to the next one, and of course we want to echo out the order at the end. Oh right, that was inside of that scope. So we're just gonna just use the same name, but technically a different variable. And that was after. So that is obviously not correct according to what we're supposed to be getting. So let's have a look here and compare the steps. Move 1, it goes to destination 2 and puts this stuff in there. Then it goes to finds destination 7. Actually, let's print out the destination as well. And that is the want cup. Yep. Aha. So we have a error here. Because for 2, so we went to the 2, we should have picked up these, and the 1 cup shouldn't have gone to 7. So it shouldn't have found that. Let me just run iterations 1 and 2. So it's just the 2 first rounds. I mean, this is the state going in. We echo out the state coming out of a step. So this is what we are echoing out for move number 1. And this should be what we are echoing out for move number 2. But since we're finding the wrong one, that doesn't quite work. So it obviously goes like, I want that one. But it says, it says that it has the cup. I mean, now we're doing the search again, which isn't terribly efficient, but it doesn't have to be here. Ring has cup to true, and then ring has cup to false. So it looks for cup 2. Am I reusing, what did I say? Why are you reusing current cup on line 29? I'm guessing that's now line 30. Does it not interrupt the current cup equals current cup next? Oh, I actually forgot to update the cup. So the current cup here. Oh, right. Yeah, we're not supposed to start. We're supposed to start from just the next one. Right. So I can't reuse this variable here. So this is the destination. There. So that's the destination. And current cup is current cup dot next. That was a good catch. That didn't work for some reason. So what's going on here? It has cup 2, so it does this. It has cup 2, so it finds that, inserts these. That is this part right here. And then it goes to the next. So the current cup here should still be 3, right? Oops. Yeah, so the current cup is 3. The next one is 2. And that was the step we did there. So it goes to 2. But here it still says 3. Did I mess up current cup? Oh, that should not be in the loop. That should be outside of the loop. I was a bit surprised when that was not in this scope. There we go. Now it gets 7. So yeah, it goes to 2. And the next one is the 5. That is good. And that's 7. I can remove our silly echo statements here. We're still going to print out that just for the fun of it. And this is going to do 10 iterations. Oh. It seemed to get stuck on this thing. Yeah, if it's smaller than... Oh. It wasn't stuck in here. Is it stuck in here? Wait, what? No. There. So it gets stuck after 5. It seems to do the right thing. So move 4 destination 7. Move 5 destination 3. As I said, this should be the state after move 5, so that should be the state of this. 9, 2, 5, 8, 4, 1, 3, 6, 7. Yeah, so that's correct. And where does it actually stop? It stops on contains and finds. So I think we have messed up some of our references, like the current next references. We actually don't ever need last. So we could simplify our code by doing singly linked rings instead. That means we don't have access to the previous one. We also don't need to take that into account. It should still give us exactly the same behavior. So at some point, yeah, so it stops at find. Stops at line 24. Yeah, so while not ring contains want cup. Oh, you know what? We need to run this check here as well. I'm pretty sure that's what happened. Yeah. So that, is that a bug in the contains for these rings? Because it looked like now that it looks like this just spun forever when it was looking for a value that wasn't in the ring. Because otherwise it would have gone down to like -1, and then this would have kicked in and fixed it. So I think contains might be broken for rings. No, but this works. Then it shouldn't have spun out like that. That was weird. Why? Because, so this, it goes to destination 3. So it's looking for 3. But why did that break it? That is curious. That is curious. Yeah, that goes to there. Those are inserted after the 3. Is it not necessary to update the head to the new first element because it's cyclic? Oh, yeah, that's a good point. Yeah, so if we take out the one that is... So when we take out these cups, if the ring then points to the wrong cup, then that would mess up. That's a good point, actually. So if you just like, oops, that was not what I meant to do. So if we were never removing the current cup, so if we just set the head to always be the current cup, then we know that the ring won't be messed up. But that still doesn't explain why that worked. Huh. But that is the... That does fix it. But then why did this fix it? Huh. Anyways, this works. Or let's check that it does work. Let's move that back to here. The order we get out is 926 583 74. 926 583 74. That's good. So if we run this for 100 moves instead of our 10, we didn't have to print them out. 6738 4529. Yes, that is correct. So if we now, instead of set the data to that, we do this, and that has a trailing new line. So we need to grab everything except for that new line. And this should be the value for our number. Hurrah! Well, that was easy enough. A bit of bumbling around, but wasn't too hard. Like, the logic isn't too hard. Due to what you can only assume is a mistranslation, you're not exactly fluent in crab. You are quite surprised when the crab starts arranging many cups in a circle on your raft. 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in an increasing fashion, starting from the number after the highest number in your list, and proceeding one by one until 1 million is reached. If your labeling were 5, 4, 3, 2, 1, the cups would be numbered 5, 4, 3, 2, 1, and then start counting up from 6 until 1 million is reached. In this way, every number from 1 through 1 million is used exactly once. After discovering where you made the mistake in translating crab numbers, you realize the small crab isn't going to merely do 100 moves. The crab is going to do 10 million moves. The crab is going to hide your stars. He's taking our stars. Really like all this highlighting, by the way. It's really cool. Under the 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels on those cups will be when the crab is finished. In the above example, 39 blah blah blah, this would be what? So the crab's going to hide your stars, 1 each, under the 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels on those cups will be when the crab is finished. In the above example, yeah, the example we just did, this would be this and this. Multiplying these together produces that. Determine which 2 cups will end up immediately clockwise of cup 1. What do you get if you multiply their labels together? Okay. So we're gonna do our normal copy of part 1 over to part 2. And this is where, if we had been using sequences, we would probably run into some issues. Oops. Part 2. Yeah, so if we had done sequences, this would probably have caused an issue because this would end up in a lot of copying. I'm still a little bit concerned about the contains and then find. It shouldn't be that bad, but we are still doing 1,000,000 cups. So worst case scenario, 1,000,000 nodes to search through quite a bunch of times. Or at max 4 times, I guess. So worst case, that could be bad. Yeah, so 1,000,000, and they're listed from the biggest one up to 1,000,000. So in here, we want to go for C, or for value in max cup plus 1. All the way up to 1,000,000. And we'll just do this so it's easier to read. This is a feature of NIM. Numbers are underscore insensitive. So do ring dot append this value. And afterwards, we of course need to set our maximum cup to just be 1,000,000. So that has added all of our cups. And we're going to do this 10,000,000 moves instead of 100. So 10,000,000 moves. And our end condition is not this anymore. Or we don't want to generate this order. What we want is the 2 cups that will end up immediately clockwise of cup 1. Which means that, well, it's the one currently labeled current cup. And I'm just gonna say A as current cup value, and current cup is current, well, we don't really need that. B is current cup dot next dot value, and then echo out A, echo out B, and echo out A times B. That should give us these 3 numbers here, because I reverted to use the example. Oh, no, don't do that. 2. So this is going to be a bit slower. Didn't expect it to be this slow. That is slower than I would have liked. Just to make sure that we haven't ended up in a loop, I'm just going to echo out the round number. This is just going to spew out output. And we're going to run this in as a release build. So it takes a bit longer to compile, but it's faster to run. Oh, wow, that is slow. Yeah, this is going to take forever. This is going to take a long time. Right. I mean, we're not waiting for that. So we are going to do this and then say while not this should be changed to destination. So as long as destination is nil, which means it wasn't found, we do all of this, and then we do this finding again. That should at least be faster. I don't think it's fast enough. It's way faster. It will still take forever though. So what can we do to speed this up? Not much, I don't think. I mean, it probably is these finds, which take a while. We don't. Okay, so what we're gonna do. So remember that all of these nodes are reference objects. So we can have multiple references to them. So instead of doing that whole find thing, I'm just going to create a table. And this is going to just be a table from int to singly linked node, I think is the correct name for those. Nope. Oh. Why is that not allowed? Invalid type for var. Oops. I can have tables with int as, yeah. Oh, because this, I didn't specify the type of the node, probably. Yeah. I can't just store any kind of node in there. Right, and then for all of these, so instead of calling this append, there's actually two appends in this. There is, well, there are many, but you have single list, one that takes single list, or we are in ring world. So one takes singly linked ring of type T and the type T, but there is also one that takes a singly linked ring of T and a singly linked node of T. So we want to create a singly linked node, like so. So here we say that our nodes, or our node for the cup, is a new singly linked node of a cup, and we append this node, and we do that down here as well. This is of course with value, and value there. So now instead of doing this find thing on the ring, which basically just loops through, runs all those references, we can now say nodes want cup. And since this is a reference object, this will be the same. This will just be a reference to the one that is in the ring. So updating this will update, like all of this stuff will still work. That is not how this works. So while, oh wait. So those nodes will then, you need to update this table, but we can do that. Or we can have some sort of marking, like we can mark them as in the ring or not. But we'll try deleting them first. See if that's fast enough. So while nodes, while it does not have the key of the want cup, we do this. So down here we now know that, same as we had with a contains thing, we now know that the table has it. So now we can go ahead and just grab it. This is not going to work because we haven't taken the cups out. So we are going to do nodes delete the taken cups value, the taken cups next value, and the one after that. And then afterwards, when we put them in, so down here, we put them back in. Then we need to say nodes taken cups, the value is equal to taken cups, and do the same thing that we had down there. And one more time. So that this might now be the slow part that makes this run slower. Oh, and I didn't echo out anything, so we can't actually see how fast that was. Way faster. Still not great. But we're up to 4 million now. 5, so we're halfway. So that should work. It's not the fastest thing, because we are constantly deleting and undeleting stuff from that table, which isn't the fastest thing in the world. And this was for our tests, so that should be 934001. Yes, and the other one should be 59. That's that, and that's that number. So this works. We can now run this on our data set and we will get the correct result. The way to optimize this, or one way of optimizing it, would be to not delete and insert, but rather have some way of marking the node as in the ring or not. And I mean, we could either mark it, or we could check if the cup is one of the taken ones or not. So if we do that, if we remove this, or just comment that out, same thing here. So basically all we're doing here is we're checking, is this one of the ones that we have taken out? And we can do that way easier by just doing something like, so if want cup, or if taken cup dot value is want cup, or taken cup dot next dot value is want cup, or if taken cup dot next dot value is equal to the want cup, then we need to update the want cup, and we can put that in a while loop. Use that, do this. This we need to do up here anyways. There. Yeah. So basically, if the cup that we want to get is outside of the, or is one of the ones that we have taken out, then we update the want cup. So instead of actually like updating the table by taking stuff out and putting stuff in, oh, that's taking cups. So instead of updating the table, like taking stuff in and out of the table and updating that data structure, or the first thing we did was which was searching through the remaining ones, we can just check, is it one of the ones we've taken out? Otherwise, we know it's going to be in there. And then we can just grab it out. This should be even faster. Yeah. Blazing fast. Well, not blazing fast, but fast enough. Actually, didn't look that much faster. Anyways, it should still work. So let's run it on our data. And just sit back and enjoy. Oh, that was quick. Hurrah! It might have just been that the bottleneck was actually printing that much stuff to the terminal. But yeah. Let's just remove this part. So I'm not sure how many, like I haven't been on IRC because I've been celebrating Christmas and stuff. So I'm not sure how many people have done this one yet. Or if anyone has done it. Yeah, sure. Keep that in. Part 1. Part 2, and our input. And I mean, there might be like some mathematical way of solving this. We are going to commit this as add day 23. There we go. Yeah, I guess on to day 24. So if I now just continue, this is gonna mess up my YouTube title. I can just go in and edit that. So let's crack on with day 24. Before we do that, I just need to check that no one has tried to get a hold of me for the past hour. We are going to my uncle's cabin later today. So I just need to keep an eye on that, whether they have gone or not. Okay, day 24, lobby layout. Oh, so we're on the island now. So yeah, these we were just playing cards with a crab and playing cups with a crab, and now we have finally reached our destination after this huge detour that we've been taking. So yeah, lobby layout. Your raft makes it to the tropical island. It turns out that the small crab was an excellent navigator. Well, that's good. You make your way to the resort. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid. This is just the Wikipedia article on hex grids for some reason. With a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side. Well, that would have been an easy puzzle. On one side and black on the other, so they're either white or black. They start with the white side facing up. I mean, my hand is the same color either side. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. The member of the renovation crew gives you a list of the tiles that need to be flipped over. My puzzle input. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile in the very center of the room. Every line starts from the same reference tile. So these are like directions to the tile we want to flip. Because the tiles are hexagonal, each tile has 6 neighbors. East, southeast, so east, southeast, southwest, west, northwest. This is so wrong doing this mirrored. And northeast. These directions are given in your list. Okay, so they're not this tiling. They're 90 degrees flipped. So like this thing, they have east and west, and north, northeast, northwest, southeast, southwest, west, and east. Instead of this, which has north and south, and the others are the same. Oh, they're not the same. But yeah. Yeah, a tile is identified by a series of these directions with no delimiters. Which is fine. That's parsable. For example, SNA identifies the tile. Oh, someone is calling me. Hold on. I'll be back in a sec. Right. Sorry about that. So that was basically I was called about when we're going to the cabin, and it's not in a very long time, but hopefully we'll be able to do at least part 1 of this before I need to go. Actually, I know I don't really have time for it, but I kind of want to give it a try. Hexagonal grids. Hexagons are the bestagons. Right, this is just code for dealing with hexagons. Might come in handy. Yeah, no delimiters, blah blah blah. Each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. For example, a line like SF flips a tile immediately adjacent to the reference tile. Oh wait, I think I skipped a bit. Yeah, no delimiter. SN identifies the tile you land on if you start at the reference tile and then move 1 tile east, 1 tile southeast, 1 tile northeast, and 1 tile east. East, southeast, northeast. Isn't that just an east? Anyways, each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. For example, a line like SF flips a tile immediately adjacent to the reference tile, and a line like east, southeast, or east, southeast, west. Yeah, that's one just below. And a line like this flips the reference tile itself, right? Here's a larger example. In the above example, 10 tiles are flipped once to black and 5 more are flipped twice to black and then back to white. After all of these instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and determine which tiles they need to flip. After all the instructions have been followed, how many tiles are left with a black side up? And all of them start as white. Okay. So let's actually open the link that I got sent by Sev. Or I'm assuming that the user called Sev here is Sev. Yeah. So I mean we are in this like orientation. So I guess we sort of want to just store a table of coordinates. And want to say, okay, let's pretend that this is our reference tile. Then moving east would be adding to this x coordinate. Moving northeast would be adding to both. Moving or southeast, sorry. Southeast is update to both. Southwest is update to west is update to only the y component. Same here. And this is update to both, one in the positive and one in the negative. So either of these will work fine. I am being called again. Hold on a second. sorry about that. Yeah, so basically we just need to make a coordinate system, and we need to store all of our tiles, and we need to decode this stuff into the coordinate system. Should be easy enough. Let's go into date 24. Nope. What? Oh, of course didn't have a date 24 folder yet. There we go. No. Okay. So let's do this. Let's grab our possible input. There. Throw on the txt extension. Some of these have a txt extension, and some of them don't, which is really annoying. So we'll just use the tables module because it can be infinite, so we can't store them in a grid. And we are going to say that our tiles is a table from an int tuple. And actually we're just going to make a count table. So remember, one flip turns them black, and then 2 flips turns them back to white. So we can loop through our ordered table and check if they are odd or even numbers. That would be black or white tiles. So we're just going to do that. And then we can just do for line in lines of our input file. And now we need to sort of parse these out. And since they have no delimiters, we need to like read. So we can't just like check for an E, because that might, yeah, we need, if we find an S, we need to check the next character as well. I wonder if maybe a string stream. Nah, we don't need a string stream for this. Position 0, while the position is smaller than the length of the line. Increase position, sort of our base ID here. We are going to grab the character at the position. If it is S, then we need to increase position 1 further, and we need to do kind of need to recurse that. So let's do a, not a template, we can't do that. Let's create here a procedure for, so we are never going to end up with south, but we don't want to write the logic for east twice. It's so little logic. This is just more cumbersome. So we are also going to need to store our X and Y coordinates. And we can do this. So since we only have south and east, we can just check if this is now the character, the character east. So that means we're moving southeast, and we know that southeast is 1 up in both directions. So southeast is 1 up in both directions. So that means we can increase X and we can increase Y. This obviously also, no, it doesn't. Otherwise, so if we're going south, but we're not going east, then we're going southwest. So that means we are going only 1 up in the in the y direction. That means we just increase y. And since we're doing this in both branches, we can just do this and increase y anyways. And if the next character is east, then we increase x as well. If it's west, we just don't do anything. Pretty much the same logic for north. So when we're moving northeast or northwest, we in both cases we decrease y. So we decrease y, but we increase x if we're going east, but we don't do anything to x if we're going west. And these are just x, y, completely standard stuff. So if we're going east, then we increase x. If we're going west, we are decreasing x. Fine, now we have our x and y. So now we can just say tiles x, y, increase. Do I need to type this up as a tuple maybe? Oh, I went with an equal sign, so not with the there. Oh, and we can technically have any other character, but we won't, so that's fine. And what is this? We can have let's see, the tables module for count table. Count table, we have contains new to a string, delete, set it to something, get or default length, smallest hash key, largest ink. So we call it like that. So just call it like this. That is of course a tuple, like so. We can also do it like this, which is now command syntax, but this is a tuple. If we did this, it wouldn't work because now we're doing function call syntax. We can do that. And then we can go through all of the values in tiles, keep a variable for the tiles that are black. And then if it's even, so yeah, if it's divisible by 2, then, or if it's not divisible by 2, then we increase the amount of black tiles, and we can echo out the black tiles at the end. Jolly good. So let's test with this first. So we'll just create a test input file here with the example, and we'll run this on the test input. It's really nice that you sort of get the test input. 16. That's a bit too many. It should be, what was it, 5 of each? No, 10 should be black. And they should have, oh, one of them got swapped 3 times. In the above example, 10 tiles are flipped once to black, and 5 more are flipped twice to black and then to white. After all of these instructions have been followed, a total of 10 tiles are black, which is not what we're seeing here. We're seeing all of them are flipped once, except for this one and this one. So this one would be white, but this would be flipped back to black. So that is not what we were looking for. So we must have messed up our thing here at some point. So we start at the 0. You know what? Echo out line at position, followed by the XY tuple. Print that out after, and print it out before. You can see all of the change. So for the first one, S, and that is of course not only an S, it is a southeast, and a southeast means, oh wait, yeah. Southeast means update in both directions. So we're counting them from 0. Wait, what? Oh no. I was doing this one. I think I've mixed and matched these two. Let me have a look at my code. So let's implement this one. So southeast is update in, there's only one direction. There's only the, no, yeah. What? Oh, it depends on if you're even or odd. Doesn't it? So from 0, 0, we go to, no, this only updates on the one axis. Oh, the column, it changes if it's an odd or even column, of course. Right. I forgot that logic. Okay, so my north and south must change. So this one is when we're odd. So 0 is an even number. So when we're even, we should only update the x direction. When we're odd, we should update both directions. So when we're doing south, if y modulo 2 is 0, so if it's an even number, then we update only the x direction, or only the y, sorry. Think y. Otherwise, we increase both, which means that we can refactor that to put this outside, and do for odd numbers also do this thing. But if we're moving southwest, then when we're odd numbers, we need to go back on both. So down one, obviously, but back on this If we're an odd number, then we only do the Y. So when we're an odd number and we're going west, otherwise, if we're going west, we should decrease X. Right. Is that correct? So we move Y 1 anyways, no matter where we are. If we are moving east on, so what is my logic here? If we're an odd number, so if we're an odd number and we're moving east, then we're updating X. If we're not an odd number and we are moving west, so if we're not an odd number and we're moving west, we need to update that. That is correct. Okay. Good. Now for north, I'm guessing it's pretty much the same thing. We need to decrease in Y, and when we are an even number, we don't do anything. Wait, when we're an odd number moving west, we don't update. Wait. Remove that. Grab this bit. So if we are, oh, and this should of course be after there. If we are an odd number, like 1, and we're moving east, then we need to update both. West does not. If we're on an even number, we only update if we're going west. If we're odd, moving east, for that, moving west, yes, that should be right. And for normal east and west, that is the same. Oop, index 34, not in 0.33. Where the crap is that? Line 35 here. Oh, right. We have sort of read past the end. That's fine. Yeah, now we have 10 that is black. That is switched once and not twice. Good. Yeah, don't print this out. Just print out the number of blacks. That is 10. And that is what we wanted to get. 10 tiles are black. So now we can run this code on our real input and get 282. That was flipped exactly once, or an odd number of flips. Hurrah! Easy enough. But I need to go now. I'm going to read part 2, but we're not going to do it unless it's super easy. The tile floor in the lobby is meant to be a living art exhibit. Every day, the tiles are all flipped according to the following rules. Any black tiles with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. So this is more sort of Conway style stuff. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. Here tiles immediately adjacent means the 6 tiles directly touching the tile in question. The rules are applied simultaneously to every tile. Put another way, it is first determined which tiles need to be flipped, and they are all flipped all at the same time. In the above example, the number of black tiles facing up is this. After executing this process a total of 100 times, there would be 2008 black tiles facing up. How many tiles will be black after 100 days? yeah. So this is similar to what we have done in the other Conway things. Basically, create a bounding box of x and y, loop through all of the coordinates, get the value from the count table, whether like to get which color they are, then check all of the coordinates around, update that, write all of this stuff into a new count table, and then yeah. But I don't have time to do that right now. But that was at least part 1. I'm going to push that to GitHub before I go. So into projects, AoC 2020, day 24. Let's see. Git add part 1 and my input. Oops. Oh. I was getting a bit ahead of myself there. There we go. Okay. So yeah, as I said, I need to run. But that was day 24 at least, the first part. And we still have day 25 left, and the second of day 24, and this annoying day 20. I still kind of want to do it just to get all of the stars, but it's so annoying. Anyways, that's it for me today. Hope you enjoyed the stream, or if you're watching this later on YouTube, I hope you enjoyed watching it. I will hopefully be back with the next parts sometime in the next few days. Not sure when. But yeah, Merry Christmas, everyone, and hopefully you have a good Christmas if you're celebrating Christmas Day today.